Every time you send an email, stream a movie, or just scroll through your phone, you're tapping into this incredibly complex global network. But what's really going on under the hood? Well, in this explainer, we're going to peel back the hidden layers of tech that power our digital lives. Okay, let's dive right in.
So what is it? What's the magic that connects billions of devices, stores just an unimaginable amount of data, and lets us build new ideas on top of it all? To answer that, you really have to start from the ground up and work your way through the entire technology stack.
All right, here's our game plan. First, we'll get into the fundamental language of the internet. Then, we're going to look at the massive digital engine that powers everything. After that, we'll meet the guardians and scribes who manage it, see how it's all being used to build a wild new reality, and finally, wrap it up by looking at the modern skill set that ties it all together.
Okay, so let's start with the absolute basics: networking and programming. These two things are the bedrock, the fundamental building blocks that make everything else we're going to talk about even possible. It all begins with how machines find each other and, well, how we tell them what to do. See, our digital world basically speaks two different languages. On one hand, you have what's friendly for us humans, right? Easy to remember names. But computers, they talk in numbers. This is where something called the domain name system, or DNS, comes into play. You can think of it as the internet's ultimate phone book. It translates that human-friendly address you type into a browser into the machine-friendly IP address that computers actually need to connect. This one idea was absolutely crucial for making the internet usable for everybody, not just engineers.
But with billions, literally billions of devices online, how do you keep all that traffic from becoming a total mess? The answer is something called subnetting. The best way to think about it is like a giant post office sorting mail. Instead of one huge chaotic pile, you create smaller, much more manageable routes, kind of like zip codes. This makes sure all the little packets of data get where they're going efficiently and securely, without causing a massive digital traffic jam.
Okay, so once the machines can find each other and talk, what do we tell them? Well, that's programming. And honestly, it's way simpler than you might think. Just look at this basic program. It's just a series of logical steps. First, you create a little container, we'll call it X. Then you put the number 100 in it. Then you do some simple math, and finally, you tell it to show the result. At their core, these simple step-by-step instructions are what power every single app you use. So we've got the language down. Now we need the engine. And that engine, for pretty much everything we do today, is the cloud. It's this massive global infrastructure that gives us the power, the storage, and all the services we need to run our digital world at a truly planetary scale. And a huge piece of that engine is Amazon Web Services, or AWS. It basically gives you all the components you'd ever need to build an application, but as a service. You need a virtual server? Bam, that's easy too. A database? You've got options like RDS or DynamoDB. A place to store a practically infinite amount of files? That's S3. It's like having a digital warehouse that's just full of every tool you could possibly imagine. And this is where the cloud starts to feel like magic. Take a service like Amazon's Route 53. When you make a request, it acts like a super intelligent traffic cop. It doesn't just find a server for you, it uses what's called latency-based routing to find the fastest possible server for you at that exact moment. It sends your request to the location that can respond in the absolute shortest amount of time. That's what makes for a smooth, lightning-fast experience online. So you've built this massive, incredible engine. Now you have two huge problems to solve. First, you need guardians to protect this super complex system from all kinds of threats. That's cybersecurity. And second, you need scribes to interpret the absolutely immense amount of data that's flowing through it. And that's data analysis. You see, protecting a system isn't just about building bigger walls. It's about learning to think like an attacker. A professional cybersecurity assessment is a really methodical hunt. It starts with just gathering public information, then actively scanning the target for any open doors, then using specialized tools to find weaknesses, and even planning how you would get data out after a potential breach. It's really like a digital home inspection, trying to find and fix every single little vulnerability. Then you've got the other side of the coin. What do you do with all this information the system generates? This is where the scribes, the data analysts, come in. For example, in just one sleep study, analysts used software to process information from 271 different people. They turned what was just a sea of raw numbers into real, meaningful insights about sleep patterns. It's a perfect example of how data analysis can transform noise into actual knowledge. So with this whole stack in place, you've got networking, cloud infrastructure, security, people are starting to build some truly radical new layers on top of it. Let's take a look at cryptocurrency, because it's a perfect example. It leverages all of this to completely rethink concepts we take for granted, like money and trust. And for this whole movement, it really all kicked off back in 2009 with this one white paper. The title says it all. The goal wasn't just to create some new shiny asset, it was to build a whole new system for digital cash that could operate peer-to-peer, without needing a traditional bank or financial institution sitting in the middle. And this is where you can really see the fundamental shift in thinking. Traditional finance, it relies on central authorities, banks, governments, to act as trusted middlemen. Cryptocurrency just throws that out and replaces that trust in institutions with trust in pure mathematics, specifically cryptography on a decentralized network. This makes transactions pretty much irreversible and shifts the whole philosophy from centralized control to what some people call the denationalization of money. All right, so we've traveled all the way up the stack, from the wires to the weird new world of crypto. What does this all mean? We've seen how all these different layers, from the most basic to the most abstract, connect and build on top of each other. So let's tie it all together. So here it is. This is the stack that basically runs our entire digital world. It all starts with the basic rules of networking and the universal language of programming. All of that runs on a massive global cloud engine. It's protected by cybersecurity guardians and understood through data analysis scribes. And now, brand new frontiers like blockchain are being built right on top. To really get a handle on our modern world, you need a basic literacy in how all of these layers work together. But here's the thing. This stack isn't finished, not by a long shot. It's always growing. Each layer that we've just talked about provides the foundation for the next, even more powerful one. I mean, think about it. In just a few decades, we've gone from simple networks to a global cloud, and now decentralized finance. So it leaves us with this one big, fascinating question. As these layers keep stacking higher and higher, what new worlds are we going to build next?